Welcome back. UV graph of convex mirror. UV graph of convex mirror. Okay. This is the UV graph of convex mirror, right? In last class, I have already drawn the ray diagram of different image formed due to different object position. So you just go through the notes, or else you go to the last class. You see, there in the whiteboard in the right side, I have mentioned what is the value or what is V for what is the condition for U. So what is V? How much is V? Where is V? Due to U. There are 5 variables starting from infinity to focus. You might have seen when U is equal to infinity, V is equal to F. Alright? In notes for convex mirror, I have drawn all the ray diagrams in descending order, not in ascending order. So you have to go through all the diagrams in the notes what I have provided to you from top to bottom, by which you can able to find the position of object is at infinity, the position of the image at the focus. In the note for convex mirror, you have to move or follow from top to bottom. Not in case of concave mirror, but in case of convex mirror. Focus on all the ray diagrams. You observe the length of the image as well as the image distance from the pole. You will see there, in all cases, in case of a convex mirror, the image form, the image position within exists within pole and principal focus. That means the maximum value of V is small f. But in case of concave mirror, the maximum value of V was infinity, as well as the maximum value of U That means the movement of object in concave mirror given in the notes and in the books extended from infinity to pole. Similarly, in case of convex mirror, the object position shifts or shifted or moved or extended from infinity to pole of the mirror. So no problem for you, but the problem arises for image distance. How to find image distance? First you have to identify where the image is formed. After finding the image position, then you have to measure the image distance from the pole accordingly along the positive x-axis or along the negative x-axis. If the reflecting surface, either in case of concave mirror or in case of convex mirror, heads or faces to the negative x-axis, no doubt the object must be placed in front of the mirror, means the object distance will be negative. Okay? So in both the cases, the reflecting surface of concave mirror as well as convex mirror passes towards left, means the object distance at different positions are measured along the negative x-axis and pole is taken as origin. That's why u became, means object distance became negative for concave mirror as well as convex mirror. All the drawings, ray diagrams, what I have drawn in the notes carries u negative. Then what must be v in case of convex mirror? You know, in case of convex mirror, or in almost all positions you will find the extended rays. Extended rays means the reflected rays are being extended. Those rays are called extended rays. The extended rays form the image. That's why in case of convex mirror, all the images are virtual because virtual rays intersects at the image form. So in case of convex mirror, all the images are virtual, not only virtual but also erect, means salakha. Virtual means abhasi. So B is negative in all cases. Case 1, case 2, case 3, case 4, case 5, Here you see, in this case, u is at infinity, not only infinity but also positive, negative. V is equal to F, positive. Why it is positive? Because the image formed let's say here is the focus, this is O of the origin, it is origin, also it is the pole, no problem, pole is said to be origin. This is positive x, negative x, okay. The image form here in between pole and principal focus, that means the length measured along positive x-axis. So first case the image is found here, second case the image is found here, third case the image is found here, in fourth case the image is found here, in fifth case the image is found here. We are taking only 5 cases, okay. So when u is at infinity, v is at f, means this one, okay. Then move to the case number 5. U is equal to F, negative. The object positions are in front of the mirror. This is the reflecting surface. The reflecting surface heads or faces towards the negative x-axis. So the length measures all the object length measured are negative in sign. So u is at f, means the value of u is negative. P is less than f and it is positive. This is case number 5 and also it is positive. So in all the 5 cases, V is positive, U negative, maximum value of V is F. Okay, over. Let's say the convex mirror or the reflecting surface of the convex mirror faces towards positive x-axis. So object will be placed in front of the mirror. This is the reflecting surface. This is a convex mirror. It passes towards positive x-axis. So object distance are positive. Then image for almost all cases, even case number 6, the image formed in case of a convex mirror is always virtual and erect, means the image fall behind the mirror. That means the image distance will be always negative when the object distance is taken as positive. So now let's say this is F. Okay, this is negative x-axis, right? This is the pole. The object are placed. The object is placed at different positions. From infinity, you have to move the object towards the pole, right? Okay. What will happen? The image will be formed when the object is at infinity. The image will be formed. Image is virtual and real and will be formed at the principal focus. Means here. Then the image, the object came closer to the reflecting surface of the convex mirror. The image form also closes towards the pole. That means in second case the image will be formed here. In third case the image will be formed here. In fourth case the image will be formed here. In fifth case the image will be formed here. This is the concept. Okay. So now for this case, U is equal to infinity, but it is positive. Okay. V is equal to F. It is negative. Similarly, the object came closer to the reflecting surface of convex mirror. Accordingly, case 2 arises, thereafter case 3, thereafter case 4, thereafter case 5. At case 5, U is equal to F, means the object is at the principal focus in front of the convex mirror. The object is not at infinity. In case 5, the object is at the focus, principal focus, and also in front of the reflecting surface of the convex mirror, and it is situated according to two-dimensional coordinate system on positive x-axis. So U is equal to F and the focal length is positive, means U is positive. U is equal to F because the object is here. So this is the focal length, this is also U. So U is equal to F and it is positive. Okay. What happened in the ray diagram? In the ray diagram, we have seen, we have drawn what? V is less than F. Not only V is less than F, V is also measured along the negative x-axis, so V is negative. Okay. See now, we have to draw a coordinate system, two-dimensional. Okay. This is X, this is X dash, this is Y, this is Y dash. Alright. Now you see positive x-axis represents the object distance. Let's say the x-axis represents the object distance. The y-axis represents the image distance. First we have to choose the quadrants. For this case, x represents u, y represents v, and x must be negative and y must be positive. So x is negative, y is positive, it is third quadrant. Sorry, it is second quadrant. Similarly, in next case, in this case, generally we draw the ray diagram keeping or making the reflecting surface heading towards negative x-axis. Means we always used to place the object in left side and the image is formed maybe in this side or that side depending upon the reflective condition of the reflecting surface, whether it is convex or concave. And the incident ray in all those cases, whether it is convex mirror or whether it is concave mirror, the incident ray always propagates or moves forward from left to right. But a person can draw the same ray diagram facing the reflecting surface towards positive x-axis. At that time, you have to keep the object in front of the mirror in the right side of the mirror. Okay, so this case is also to be considered in case of convex mirror as well as in case of concave mirror. In concave mirror, we have chosen first quadrant and third quadrant because u and v both have same sign convention. When u is positive, v is positive. When u is negative, v is negative. That's why the UV graph, which one was a hyperbola, the UV graph, which one was a hyperbola, drawn in first and third quadrant. But in this case, u is negative, v is positive. While u is positive, v is negative. So the graph to be drawn in second quadrant and fourth quadrant. Okay, let's start now. You see the maximum value of V is F. So take a point here. Maximum value is F. Okay, you take a point here. Maximum value is F. The maximum value of V is also minus F in this case. Okay. Now, when B is F and positive, U is infinity. In this case, the maximum value of B is F, not infinity. B is F. The maximum value of B is F, and it is taken as negative. So take the point in negative y-axis because y represents B. So B is negative at the time U is infinity. Okay. Now, you see here, the image gradually closes to pole. The image gradually becoming closer to the pole. At the same time, the object is also closing, becoming closer to the pole. That means when the object is at the pole, no doubt the image will be also at the pole. But pole stands for origin. Pole can be represented as origin. Okay? And the principal axis can be represented as x-axis. One side is positive x-axis, another side is negative x-axis. So when the image comes closer to the pole, at the same time, the object also comes closer to the pole. That means when U is equal to 0, V is equal to also 0. Okay? So now, here is a point. V is equal to 0. But this case never happened in case of concave mirror. Only happened in case of convex mirror. When V is 0, U is also 0. Okay? Now, when V is F, this is F. When V is F, U is infinity. Okay, draw the perpendicular. This particular line intersects the curve at infinity. Okay. This is F. When V is equal to maximum value of V is this. So V is equal to F, either plus F or minus F. U is infinity. That means at the point F, you draw the perpendicular. Let's say both the lines intersect at here, and this is the x-axis. Okay, draw the perpendicular here. Now this much is u. Remember, this is u. That means u is infinity. How much is b? B is f. U is infinity. B is f. In this case also, you extend the negative x-axis. Let's say here the intersects. That means at this point draw a perpendicular. So let me say, when b is plus f, u is minus infinity. When b is plus f, u is minus infinity. In this case, not here. Here. When b is negative f, u is plus infinity. When b is negative f, u is plus infinity. So both the cases over. Now this is the graph, UV graph of convex mirror. Keep in mind, in convex mirror, the UV graph, the curve generates in second quadrant and fourth quadrant. In case of concave mirror, the hyperbola generates in first quadrant and third quadrant. Okay, this is all about the UV graph of convex mirror. Then you see what are its use? What are the uses of convex mirror? Convex mirror is generally used to see. Convex mirror is generally used to see rear views. Rear views means pacha दृश्य पछे घटुवा दृश्य को आमे कन्वेक्स मिरर रे देखि पारो. That's why commonly for that reason it is commonly used in all vehicles. सबु जानवाहन रे आमे कन्वेक्स मिरर देखिबा पाऊ. कन्वेक्स मिरर रे पछुआ आसुथिबा द्रुत गति रे आसुथिबा बा ଯେତେ ବଡ଼ ବିରାଟ କାୟ ବଡ଼ big in size or small in size, whatever may be the size of the vehicles, but the vehicles coming from the back easily can be seen by using this mirror in the driving vehicles, the vehicles which is driven by the driver. Okay, so it is commonly used in all vehicles because rear views means behind views, means behind scene and sceneries, whatever else behind, we can easily see using convex mirror. Okay, let's move to the plane mirror. UV graph of plane mirror. In case of plane mirror, you see what happened. Let's say an object is here. Draw a line perpendicular to the mirror, surface of the mirror. Let's say it is a point object. Okay. The incident ray moves forward. This is the point of incidence, and it returns back because I is equal to R is equal to 0 degree. Now let's say another incident ray moves here in this direction, strikes the surface at here. This is the point of incidence. Another point of incidence is here. Okay, what happened? You have to draw the normal here. Again you have to draw the normal here. You see, I is equal to R, this is I. So now, this is R, I is equal to R. Okay. Similarly, this is the incident ray, this is I, and this is R. Okay, this is R. Now, what will happen? You have to extend those reflected rays. Okay, go on extending. From here also, go on extending. Okay. Here you see. Here you see what is happening. This angle is equal to this angle. This angle is equal to this angle. Alright? But both these angles are same. I is equal to R. So this is equal to this. This is 90 degree. This is the common side. So this triangle is congruent to this triangle. That means this is equal to this. Congruent means सर्वत भावे समान. ताले एक त्रिभुजटा एक त्रिभुज सांगे सर्वत भावे समान. So now tell me. Okay. This is equal to this. What is this? This is u, object distance. Then from here to here, what is this? This is v. Okay. Here you see what happened. If we use the coordinate system, this is plus x and this is minus x, negative x axis. So when u is negative, b is positive. When u is negative, b is positive. Not only this, u is equal to b when u is negative and b is positive. Both the length same length, but sign convention according to coordinate system, u is negative because it is measured along the negative x-axis from the reflecting surface. So u is negative and b is measured along the positive axis from the reflecting surface, means from the origin. So it is taken as positive. Here u is equal to b and u is negative, b is positive. Okay, turn it up. Now, the reflecting surface of this plane mirror faced towards right, towards positive x-axis. Okay, draw another diagram. This is I. This is R. This is I. This is R. Extend it. Okay, the same thing happened. Okay, the same thing happened. This triangle is compared to this triangle. Okay, now this is 90 degree. And this angle is equal to this angle. This angle is equal to this angle. These are both the angles are same. So this is equal to this. This is the common side. Okay. So now this is equal to this. Here you see what is happening. In both the cases you see here this distance is taken as u. This is u. Because the object is kept on positive x-axis. The mirror is passing towards right. So now u is, and this is the distance, and this is as v. V is measured from the reflecting surface along negative x-axis. So what is here? Here you may see U is equal to V, but U is positive while V is measured along negative x-axis. These are the extended rays. Okay. This is negative. X dash Y dash origin. One thing you see, x-axis is taken as object distance, y-axis is taken as image distance. Y represents V, X represents U. Now tell me, when U is negative, V is positive. When U is negative, V is positive. So the UV graph occupies or occupying where? In second quadrant. And next, in this case, fourth quadrant, because U is positive and V is negative. This. Now, the magnitude of U is equal to the magnitude of V. Means object distance is equal to image distance. Object distance is equal to image distance. Sign convention is different because it is measured in opposite direction. In physics, sign convention only gives the direction. It doesn't affect the magnitude of any physical quantity. Let's move. Now, when U is taken is this, you have to take the same amount of V, because at the same moment V is this. Draw the perpendicular. Draw the perpendicular here. Here is a point. Similarly, you take the U this much. Okay, take the same amount here. V. Draw the perpendicular. This is another point. So it is clearly proved, it is clearly seen that it will be a straight line. The UV graph in case of a plane mirror is a straight line equally inclined to both axes. Equally inclined to both the axes. It is a straight line equally inclined to both the axes. What is the use of plane mirror? Plane mirror commonly used in our day-to-day life. ସକାଳୁ ଉଠିଲେ ଆମେ ଆମ ଫେସ୍ ଦେଖୁଛୁ, କୋଉଥିରେ ଦେଖୁଛୁ? ପ୍ଲେନ୍ ମିରରରେ ଦେଖୁଛୁ. Everybody, not only me, but also everybody. So it is commonly used in our day-to-day life. For viewing or looking our face as well as body. Next, one more thing I want to tell you about plane mirror. It is also important because you see, in case of plane mirror, you know U is equal to V. Let's say U is equal to V is equal to X. According to sign convention, if U is equal to minus X, V is equal to plus X. It may be measured in centimeter or millimeter or meter, whatever may be. Whatever may be the units, doesn't matter. But U is minus X when V is plus X. Let's say U is equal to V is equal to X units. Okay? So now, applying in mirror formula, one by V plus 1 by U is equal to 1 by F, implies 1 by, this is X, plus 1 by minus X is equal to 1 by F, implies 1 by X minus 1 by X is equal to 1 by F, implies this cancels, 1 by F is equal to 0, implies F is equal to 1 by 0, that means infinity. So in case of plane mirror, focal length F is equal to infinity. So R is equal to, radius of curvature is equal to 2F is equal to 2 times infinity. That means it is also infinity. Okay, all the best.